I keep it a hands-on session and it should be interactive. If I ask questions, I should get answers from everyone. Okay? So, how many of you have laptops with you right now? Okay. So, I will teach you how to install the IDE for the Son Papdi board, and you can install it. Then, meanwhile, it will get installed. We will study the RISC-V basics, and then we will design a processor on the IDE. Okay. So this is the Son Papdi board. So it have a ICE40 IC on this, and they have created this board entirely in India. Just this chip is by Lattice Semiconductor. Apart from this, this whole board is entirely made in India. So we will be learning about this. So Hardik will join us and will tell us more about this board. So meanwhile, we can start installing the toolchain and IDE for this. I hope my screen is visible to you all.
Yes, your screen is visible.
Okay. So I am sending you this drive link, and you can install if you have Linux, Mac OS, Windows. This IDE is supported for all of these, and this is the JSON file which you have to replace. I will tell you how to do it. So you download this, and when you will download it, you will get this zip file, iStudio zip file, and you will open this and you will get this iStudio, and then you can install it. So this zip file is created so that it is easy for you all to install the IDE. So now after this, you have to install the toolchain. So you can, here will be an option to install the toolchain. And for installing toolchain, you have to make sure that you have installed all the dependencies like Python and everything. It is there. And if you get any installing this, you can just ask ChatGPT what the error is, and it will tell you the solution on how to solve it. So I hope you will all install this. Now, when you will install this IDE, in the view you will go, there will be a command output section there. So it will help you know where is the path of this IDE. So this is, as you can see, this is my IDE. I will go here. So in the VNV folder, there is a lib. There will be a lib folder. In this, there is Python folder. Inside packages, you will go in this APIO folder, and here you will click on resources. And मैंने आपको ये जो ड्राइव दी थी, ड्राइव, इसमें एक board.json की भी फाइल है. आपको जब आप इंस्टॉल करोगे, जब यहाँ से आपने जैसे कि आपने लिनक्स इंस्टॉल किया या फिर मैक ओएस का इंस्टॉल किया, तो फिर आपको उसमें पहले से एक board.json की फाइल मिलेगी. आपको उसे इस वाली board.json से रिप्लेस करना है. आई होप यू ऑल अंडरस्टैंड व्हाट आई एम टेलिंग यू ऑल.
Yes, yes. Yes, please continue, Anushka. Mac, like OS.
Uh, yeah, can you repeat?
We were discussing about OS setup, like what to do with JSON file, which is on the drive.
Okay, so you have seen this, how to what we have to do for the board.json file.
Yes.
So here is a Python folder. You go to the lib. You know how did you identify this path? So for this, identifying which path you have to find the board.json file, you will have to open the and just search here, and you will find this Python folder, site packages, and here is APIO, and in resources, you will get the board.json file. So you will replace that board.json file with this board.json file, as you can see here, which is there in the drive. So I hope uh, you all will follow what I am doing. So if you want to learn on how to use this IDE, you can. I am giving you some resources also, which you can follow. Wait a minute. Till then, you all can install. So to learn how to use this ID, you can follow this documentation, which I have sent in the messages. So as you can see, it have told you need not follow this how to install drivers and everything. That is separate for Son Papdi FPGA Board. But how to create a project, like as you can see here, everything is told in detail how you can do it. So when you have board.json file, as I have told you, you will go to the tools in the in you will go on the boards section in the select tab, and here you will find the Son Papdi board when you have changed it. As you can see here, the Son Papdi board is visible now. So just click on it and the Son Papdi board is here. And you will also have to install the tool chain. In the tool section, there will be a tool chain section. You will have to install it. So now you can create your basic circuits in this. Like if you want to add a Verilog codec, so you have to go in the code section. You have to tell the input ports, output ports, and the parameters, and just click on OK. So this is our code section where you can write your Verilog code and you can create your Verilog design with this, and you can verify and build and upload on your board. And then with this, you can also create SOCs with this tool. Today we will be learning how to design a RISC-V processor, but you can also create SOCs with this tool. So I will show you an example of SOC. As you can see, this is a SOC example which you can create with this ID. So here is the RISC-V processor, and here is the UART, all the things which is necessary to create a SOC. It is there. Here's the RAM memory. Now, how to design this? How you can design like this as it is shown here, we will understand it. So before that, let's understand about RISC-V. So RISC-V, we will first understand the basics of single cycle RISC-V processor. And then we will move on to the pipeline RISC-V processor. So we will understand this with the help of the example program, as you can see here. So this is the example assembly language RISC-V assembly language program. So let's understand how the first line of this RISC-V assembly language will work. So as you can see this, the load instruction is a I-type instruction. So RISC-V had instructions type, as you know. So this is the types of instructions in RISC-V: R-type, I-type, S-type, E-type, U-type, and J-type. So these are the formats of the instructions. So we will learn that how the I-type instruction will work in RISC-V. So as you can see, this architecture looks a bit complicated. So we will understand it step by step. So anywhere you find doubts, you can ask me. So is the screen visible?
Yes, yes, Anushka.
Yeah. So yes, Neil. So it is the same file. We have Hardik also in the meeting. So he will also help you all with the setup of the IDE. So to know the location of board.js, you have to go on the command output section. So there will be a hint that what is the path of that. So Hardik, would you talk on this? On the board and the setup on Windows and Mac
Yes.
OS as well?
So, Akash, I will share the exact path where you need to replace the board.json file, and you can copy that path and just paste it. Hello,
Yeah.
am I audible?
I hope the doubt is clear. Okay. So let's understand this RISC-V processor step by step. So the first step is that so the PC will be initialized with the address of the first instruction which we are executing, which is 1000. So address in the PC will act as an input to the instruction memory. So, so the instruction memory will fetch the machine instruction for the current instruction. So the machine format for the instruction which we have here will be, this is the, as you can see, this is the example program. So the initiate of this will be written like this. The RS1, the source register one will be written like this, F3RD, and the opcode. So if we convert this, all this to a machine language in hexadecimal format, we will write it like this. I hope you understand this. So this is the I-type instruction format. So the bit 20 to 31, 12 bits are for the immediate. This is for source register 1, and this is the point 3, and this is the destination register, and this is the opcode. I hope you know, you understand what I am saying. If you have any doubt, you can ask regarding this. So let's so as you can see, this is the first step. I hope you understand that how we got this machine instruction for the current instruction. So the register file will fetch this. So the first thing is that the instruction memory will fetch the address from the program counter, and it will give the machine format of the instruction file. So the next thing is that we will decode. So this is the value 9 which corresponds to register X9. So the register file reads the value which is in X9 register, and we assume that the register X9 have 2004 as the value in that. So as you can see, X9 you can see is the RS1, As you can see, this is the source register. We have, it indicates it is X9 and 2004 is stored in that. So the register file will fetch that and give it as an output, as you can see here. So now we will extract the immediate. So this is the immediate, as you can see here. Let's see the immediate. So bit 20 to 31 is the immediate, and we will sign extend it. With- We will why we have to convert? We have to sign extend it because we have to convert it to a 32-bit value. So presently, this is a 12-bit immediate, and we have to convert it to 32-bit value. So for extending the immediate, we will introduce a new hardware block. So it will extend the MSB, which is the sign bit, to the higher bits. So we have introduced a sign extend block, as you can see here. So this will extend it and give it the extended number as the output. So now what we will do, next step is the ALU operation. So we will add the base register and the immediate. So from the source, so we will take the output from the register file and the output from the sign extended block and add it. So that ALU also the signal 0, and which indicates that it is the addition. So as you can see, this will be added here. So are you understanding what I'm explaining? Have you studied all these things before? Okay, so so MIPS and RISC-V are both different architectures. But they both are not same MIPS and RISC-V. Okay, so is my screen visible to you all? You can't change the size. That all these things are given by RISC-V, and you have to follow that. You can't change the bit size of instruction set accordingly. You have to follow the RISC-V specifications, which is there on their website.
Anoushka, your screen is not visible.
able to present it. I hope that now you can see the screen.
Yes, now it's visible.
So as you see, we have done the ALU operation. So the output of the ALU will be stored in the data memory. So now we can assume that the output of the address that so as we have got this output. So the data at address 10 at 2000 is the 10. Okay. So so as you can see, this is the 2000 location which we have got from the ALU. We have 10 stored in the stack. The 10 will go here to here and will be stored in the register file. You can see here. And it will be stored in the destination register. So the and we have write the data. So in the data, the write signal will be 1, and we will write 10 at the x6 register. So the more similarly, we have to construct R type. And if you want how the types of instruction work, you can read the David Harris book. So you can read the David Harris book if you want to learn how you are. So this is the pipeline RISC-V processor. I hope you know how all this works. This is a 5-stage pipeline. So just now we have seen that how instruction is fetched, how it is executed, and how it is stored in the memory, and how the write back operation works. So these concepts are very important on how will the pipeline RISC-V processor will work. So now we will discuss. So this is our code which we will understand. So at every clock cycle, a new instruction will enter the pipeline. As you can see here, here is our pipeline. So at every clock cycle, as you can see here, here is our clock. At every clock cycle, a new instruction will enter the pipeline. So while one instruction is executed, like this instruction one is getting executed, at the same time, the second instruction will also be fetched and that will be executed and decoded, and then the other will be fetched. So this overlapping of the instruction, as you can see here, it improves performance single cycle. So it uses a register. So this is the it uses a register called as next program counter uh, to track the instruction address. So this is our program counter. So then the program counter will go to the the branch target address. So I think you're understanding what I'm explaining. So the fetch instruction is stored in the instruction register, and as you can see here,
Anushka, your voice is breaking.
am I not audible?
You're audible, but your voice is breaking a bit.
Okay. So this is our code. So we have given the clock as a input, and these yeah, actually
Iris, Iris. Actually, Anushka has some network problems, so I think she won't be able to attend anymore, like join again. What we can do now, we can reschedule this session and continue it on Monday. She will be doing it the same on Monday. Till then, what we can do now here, that she had shared the drive link and the tool chain setup she explained just now. So what we can do now, you can set up the tool chain, and then on Monday we can start working and designing the RISC processor from the scratch. If anyone have any query, you can ask.
Yes, anyone who is facing any issue in the installation process, so please let me know, and you can contact me on my number, and I will share in the chat box. So you can contact me, and I will help you to install it.
Yes, I am also sharing the links which she had shared earlier for those who have joined late. The drive link which have been sharing just now, and the contacts for Hardik's contact if anybody has any problem in setting up the tool chain. So I will just re-announce the setup that again on Monday at some in the afternoon timing. I would be rescheduling this whole setup and resharing from the Anushka's profile.
So, Hardik, would you like to tell about the Son Papdi Board to our students?
Yes. Okay. So Monu is asking something. Monu. Hello.
एक्चुअली आई वाज आस्किंग कि मीटिंग अगर अभी रिकॉर्ड हो रही थी तो हमें रिकॉर्डेड लेक्चर मिल सकता है, तो हमें सेटअप करने में इजी होगा.
Okay. Anoushka, we are recording this.
So, Swaroop, are we recording what we are doing?
I have started the recording, but I'm not sure it is like from the start or not. I will check in the end, and then I will share it in.
Monu, don't worry about the setup part, and I will help you. And if you have any doubt, just let me know, and we will set up on your computer.
Okay, thank you so much, sir.
हाँ, अगर कोई भी इश्यू है या फिर कुछ भी प्रॉब्लम है, so feel free to call me or email me. You can send, but please send some screenshots कि कहाँ पे error आ रही है, so that we can resolve it. Is that fine? Any other questions so far for the installation process? Okay, so I will share my screen, and just a second. So my screen is visible?
Yes, Hardik, it's visible.
Yes. So as Anoushka told, this is Son Papdi FPGA Board. So this is the website. This is a product website, and so we have written this article about Son Papdi FPGA, like what we have on the board and why we have designed this. So we have published an article on Hackster. So this is the article, and so as Anoushka told, like this Son Papdi FPGA work on this block-based IDE. So the good thing about this is if anyone who is not into VHDL or Verilog, so they can program Son Papdi with the help of these blocks. So they don't have to write Verilog code. With the help of these blocks, they can deploy the Verilog code. So it is very beginner friendly and very easy to use. And let's understand what we have on the board. So on the top side, we have these 8 yellow LEDs. So why we choose 8? We choose 8 because 8-bit data is very common. So when we build things like counter or any circuit, so we can show the output on these LEDs. So like this example, in this example, we have make a 8-bit counter on the Son Papdi, and we are showing the states on these LEDs. So if anyone has any question or any doubt, so please ask. Feel free to interrupt me and ask. And right next to them, we have these 4 white LEDs. These are status LEDs. So while we are doing some arithmetic operation, if any carry is generated, so we can show them all the status on these LEDs. These are status LEDs. And on the bottom side, we have these 8 switches. So we have separated them in 2 parts, set A and set B. So with the help of set A, we can input 4-bit numbers into our circuit, and set A and set B. Like if we enter 1001, so we have to toggle this one, 0 for 0, and 1 for A1 should be on. So similarly for set B, we can perform addition, subtraction, and show the output on the LEDs. So on the right side, we have 10 GPIO headers. So with the help of these GPIO header, we can connect external sensors. Like we can connect IR sensor, ultrasonic sensor. So we can connect different type of sensors and modules with the help of these GPIO pins. And this is where things get really interesting. You can connect soil sensor or interact with the real world environment and connect your FPGA and make some algorithm based on it. So Son Papdi is based on lattice size 40 FPGA. So the good thing about this FPGA is it is open source. So anybody who wants to make projects, so they have really good examples out there. So they can install them and see how it is working. So a fun fact about this FPGA is a similar type of FPGA, ICE40 family, is used in iPhone 7. A part of this, we have also created a YouTube series of digital electronics using Son Papdi. So you can check out this. So this is available on YouTube. So this is ongoing lectures. So we are adding continuously. So right now we have 7 lectures. And these are the basic example. Yes, Neil.
Hi. So is this going to be completely on this block-based platform, or are you going to cover some Verilog code as well?
Yeah. So the thing is, you can also use Verilog code. If you want to use, you can use. So we have both options available. So you want to write it, you can use. And if you are not familiar, then you can use block-based. So we are flexible. So we don't bound students to use block-based only. So you can use both.
Okay.
Yeah, I will teach you how to use this ID better when we will design a RISC-V processor on this. So meanwhile, I've sent you the iStudio documentation in the chats. So you can go through that, understand how this works. And you should also go through the David Harris RISC-V book. And if you want to make your computer architecture basics strong for learning RISC-V, you can also you should actually refer to owner module lectures.
Yeah. So like here we have these bunch of examples. When you install the IDE, so we have these 6 sections. The one is basics. On basics, we have some examples like toggle the LED, blink the LED, and how to light up multiple LEDs like this. And similarly, we have bunch of examples here. Like this one is the AND gate, simple AND gate. When you toggle A0 and A1, D0 lights up. And another is OR gate, and this is 2 to 4-bit decoder circuit. So all this we can make in this iStudio. And once you are comfortable with these examples, we can also make advanced projects like running this RISC-V CPU. So all this is open source. So if anybody wants to learn, so they can go on the GitHub repo, like this RISC-V FPGA. So you can start exploring. So this is all the libraries and all the source code is open source. And here we have the specification. And this is the pin diagram, like which LED is connected on which pin. So this is clearly mentioned in this image. And yeah, that's all about it. So if anyone has any doubt about the board and any other question they want to ask, so I will share the link of this article in the chat box, so you can read more about it. Guys, any question?
Is this board
Sir,
available on
sir.
Robo?
Sorry?
Is this board available on Robo or any other platform apart from the website?
So right now it is only available on our website,
Okay.
and we have just developed. We are kind of like launching in few days. Yeah, someone is asking any other question. Hello, am I audible?
Yes, you are audible. If anyone have any other question, they can ask.
Sir,
Yes.
sir, in the board there is a several GPIO pins. Why did you not add any protocols on the GPIOs?
In FPGA, you can run any protocol on any pin. So we don't have to specify like these are the I2C pin. You can choose any pin and make it I2C or SPI.
Okay, sir.
Yeah. Any other questions so far? Yeah. Some questions in the chat box. Sandeep Kumar. So if I want buy this board, what things we get? Okay. So if you buy this board, you will get the board delivered on your address, and you have the YouTube videos. With the help of it, you can learn about the FPGA and Verilog. And what is can board connect via Bluetooth by serial communication? So you Shivam, you need to connect a BLE module to it on the GPIO pins. So you have to connect a SC05 module, and then you can communicate with Bluetooth. Monu Goswami. Can we have GitHub link? Yeah, I will share the GitHub link. Just a second. Yes. Just a second, I am sharing the GitHub link. Studio install projects. So here is the GitHub link. Okay, so Jay is asking any ADC. Yes, we do have ADC. So I will share the data sheet of the board. Okay. Actually, if you read the article, it is all these details are mentioned there. If you go through this article, I will share it again, the extra article. So we have written all the details about the board and technical specification in the bottom section. You can look into it. I'm just curious, where does the name comes from? Okay, so we are designing this when our Diwali holiday. तो generally मैं Twitter पे post डाल रहा था. So somebody reply to it and call why if we can name it Son Papdi or not. So initially मैंने सोचा कि like कर सकते हैं या नहीं. Then my another partner Piyush who works in Google. So then he suggests like if Google can launch Lollipop or Marshmallow as their versions, so why can't we launch Son Papdi? So that's how the name came up. Any other question? Thank you, Akash. Okay, I think you guys you don't have any question. So if anyone has any question or any doubt, so you have my number. You can directly connect with me.
So if anyone don't have any question, we can reschedule this meeting again on Monday, where Anoushka will discuss further about after setting up the tool chain. We will be discussing how we can design RISC-V processor on FPGA. I will just make sure that if everyone have like joined on Anushka's that community on WhatsApp. So in that community, she will be posting the time. Otherwise, it will be around. I have to discuss with Anushka. So it will be around after lunch. Better to be on like after 2. So on Monday there would be a session on that. So I think that's the wrap up. There is a question from KK. Can we implement digital FIR filter on this FPGA? I think in FPGA we can design any sort of digital logic. Rather, Hardik will specify.
Yeah. So we have to write a Verilog code, and we can design the digital FIR filter on this FPGA board.
So I think this sorts out everyone's queries. So we should. And I would like to thank you, Hardik and Anushka, both of them, for their time on this event. And will like how to give input to it.
So those are GPIO pin, general purpose input output. So we can any pin we can take input, or any pin we can take give output to it. So it is convertible.
I think I think the speakers have left the meeting. We can continue the discussion on Monday, where we will discuss the rest of the doubts which we have right now. And yes, we can run AI modules. It's just about making the Verilog code and writing the Verilog. There is a limitation of 5,000 LUTs. And there would be a limitation of some number of DSP slices. So based upon that, whatever that size limit can we can like make any sort of digital logic or any other. So I will try to include all your doubts also in the next session, including Jazz, which he is asking about how to use UCF to map GPI. Okay, so I will make sure that this will be included in the next session. Thank you all for joining right now. I will make sure that the recording of today's lecture will be available. Otherwise, the next Monday's session would be recorded for sure. I wasn't that prepared for the recording and the starting, so I might miss the starting part of lecture. So thank you all for joining. You can all leave now. You are welcome. Make sure to join on Monday. We will be having the next session on Monday.